Night Watch Institute, Node 3. The topic of today is going to be the expansion of the universe and why it matters. And first, to kind of understand the context of it for those who aren't familiar, you've probably seen the age-old equation E equals mc squared, or energy equals mass times the speed of light squared. But not too many people realize that what that means is mass is literally just energy that has slowed down. So one of the big questions that physicists are trying to answer is, why does energy at the initial time of the universe slow? Why did it become mass? How did it become mass as a result of slowing down? So one of the things that they have managed to figure out so far is that atoms are not made of even smaller upon infinitely smaller building blocks, but at some point they are just waveforms that have interacted together. You can have many different types of waveforms all around each other and interacting, but not necessarily creating mass. However, if the collision between any of these energy waves manages to slow down the wave enough, then there's a good chance they'll become mass. Just in case you're not as familiar with the concepts of frequency, in this particular context, the wave frequency is basically just how far you have stretched the information in that wave. The initial energy and the initial information and energy within that wave, as it gets expanded, you've lowered its frequency, ergo its vector, its speed. It is more likely to become mass. So the higher up in the energetic scale you get in frequency, the closer you are to pure energy. The lower in frequency you get, the closer you are to pure mass. The difference is only the speed with which they are moving. That's why either can become the other. But the big question overall right now that quantum physicists are attempting to figure out is, why did they start to interact in the first place? Why do some wave collisions result in mass and others don't? And what else can result as a result of these collisions? So you can have many different types of waveforms colliding but never resulting in mass. So if you can imagine at this point, I haven't finished chalking out the rest of this, but if we zoom into this area, and you can see that there's three masses that result from these energy collisions. So if we were to try and represent this mass overall, we could say it is three separate masses that have resulted. Okay? The mass itself is there. The energy and whatnot is still around it. But space itself only exists in a volume that is described by the surface area. Sorry. The volume of it is described by a surface area that is exactly large enough to contain all the information within. So that's why the universe expands as best I'm able to tell, is because your energy itself, at least at present, is constantly expanding. Ergo, the space around the energy itself has to expand to accommodate, or the volume and the surface area has to expand to accommodate the increase in information. So what is it that causes the increase in information? Well, it would really, at the very least, one of the things that we know of that causes an increase in information is the interaction of energy upon mass. So going back into this area, you see, we started off with just 3 masses, but now these masses are going to be out there, and they in turn will continue to interact with other waves in different forms around them. So you might have, if gravity was a wave, it's going to be affecting mass in a particular way. If kinetic energy, or a different type of energy is another wave, or radioactive, you get the picture. Different energies are going to react with masses, and different masses in different ways. But when that happens, some of that energy is transferred into the very shape and waveform itself, causing it to either increase or decrease in frequency. It doesn't always decrease, but something has to. So you'll have kind of an equal and opposite reaction effect. So, among the waves that are there, you might start off with a dual, with a wave that appears to be one solid wave, but then as it separates, it gradually becomes, as it slows down, it gradually becomes 2 separate waveforms because they were only identifiable as it slowed down. So that is the gist of what quantum physicists are looking for, and also why the universe itself is expanding. Now, the big question there is, okay, so if the universe is expanding, what's it expanding into? Well, it isn't actually expanding into anything. It's just inflating. If you can imagine a balloon. All right, now imagine, actually we'll just use my hand here, okay? So let's imagine that the entire universe consists of only 5 energies. And we'll just, just for the, for tradition and argument's sake and stuff, we'll narrow it down to the 5 basic, earth, air, fire, water, and spirit, okay? Now, obviously, they're going to have different names, they're going to be different elements, whatever. But because I have 5 fingers, it makes it a lot easier to break it down into that. So let's say those 5 energies are all that is there right at the beginning of the very beginning of the universe, or at least the smallest point at which we know. It's entirely possible that there might have been the universe there before and it had a contraction period and then it went back to an expansion period. But either way, if this is all the energy that is there, you don't get any more fingers. You don't get any more skin. You don't get any more stuff in here to make these fingers. All they can do is expand outward. You're not actually on the edge of space anywhere. Even if your little part of mass was created on this fingertip and my mass was created on this fingertip in a different area, and someone else's mass here, and as we get further and further away, unless there's something tying all of us to notice relative to each other, we're not really going to know and care, because we're going to be far more worried about our localized environment where things are still expanding over there. So at every single fingertip, there's going to be more fingertips coming out, and at every other fingertip, there'll be more fingertips coming out. And you see this in nature all the time with fractals. So it's not so much as that they're trying to find initial building blocks of the universe, but rather they're trying to figure out what it is that could be produced at the beginning of the universe as a result of these pure energy waveforms. Because if they can narrow down those specific pure energy waveforms again, then they can create new materials that potentially our universe could have had if waveforms had reacted in a different way at a different frequency. So there, I guess I I guess I took care of multiple birds in one stone, but the point is, when the universe and when space-time expands, it's not like there's an edge to the universe. Even if you had situation like this, where space was on a universal macro scale, just slightly measurably bigger than the universe, and all the mass that was in it. If you imagine this like a balloon, we'll even have our little edge of the balloon here, and our little string, and this is before it's ever gotten any air in it. And then as the balloon expands, you haven't added any more rubber. You haven't changed anything except expanding the area. And so this same exact amount of mass that was here at the very beginning of the universe is now hypothetically dispersed all around the universe at every location in space. So when you expand yet again to an even larger, well, that's not really that much larger, to an even larger form, and we'll just kind of do comparative expansions outward. Right. So if you had, at the absolute teeniest, tiniest portion of the universe, you had this one little dot, it's going to become that, then it's going to grow out to that much, and then it's going to grow out to that much, and it's going to grow out to that, but it's going to become progressively thinner and thinner and thinner as space-time expands. And the time itself doesn't even necessarily exist in this spectrum. It's not like this is expanding because time is passing. Time is simply used as a convenient measurement tool to tell how far mass has expanded or contracted, space, or wave frequencies, or things like that. Time is just a useful descriptor. It is not limited to a direction. It's not limited to two directions. It's not even necessarily limited to a 360-degree sphere around you, but in every conceivable direction, on every conceivable point of that sphere. Expanding all the time. But it might not even necessarily be noticeable to you because the parts of that first initial teeny tiny little dot that were closest to you are still going to be the same portions of that teeny tiny little dot that's closer to you, only a bit further away. But then we battle the force of gravity, which may or may not be a wave and does appear to increase with mass, though whether that is a function of gravity's own wave form or an inherent property of mass as it collides with a particular type of wave, we don't know. That's one of the reasons why the Higgs boson particle was so important to try and figure out where mass came from, because the idea is that there must be a sticky waveform or something to that effect that causes other waveforms to act upon it and actually slow down long enough to become mass. Now they think there's more particles in it. As for what is the air that expands the balloon that is our universe, well, one of the theories behind that is dark energy. So we're not talking about energy from like some sort of a dark sun, or energy from a black hole, or energy that is dark instead of light. It's referring to what is this force? What is this air being blown into the balloon to increase the size of the universe around us? And is it just that is doing it? Is it just that influx of air or dark matter? Or is there other stuff that's influxing as well? And if stuff is being brought into the universe to expand it, where's it coming from? Where's it going? Is it exiting? If it's exiting, where? When? What space-time? So I hope this helps to clear up a few questions, and I hope even more it inspires you to ask a million more questions, because we need more people looking at these sorts of problems. This is Node 3 and Minnie signing off.